Section 11.3, pressure and volume, which is also known as Boyle's law. Now for me, I don't really care that you know that Boyle's law is the relationship between pressure and volume, but some people, it's important to them, so, you know, great. So pressure and volume, they show an inverse relationship. So let's take a look at what that means. If I'm going to have the volume down here, which is what I'm purposefully changing. Now that's the volume of the container. Okay, it's not the volume of gas, it's the volume of the container. Over here is pressure. Let's say volume is going to be measured in liters, pressure is going to be measured in atmospheres. What we see is that when the volume is small, the pressure is huge. And when the volume is big, the pressure is small. Now, this is of a container that can expand and contract, so here's an example. The other caveat, the number of gas particles inside does not change. Okay, so we see a graph that looks like this. That's an inverse relationship. Okay, now what we find is that that pressure and volume is proportional to some constant K. But this isn't really too useful of an equation, so instead what we use is down here. P1 V1 is equal to P2 V2. Now I always just teach the combined gas law, but just to let you know what this is the initial pressure, and this is the initial volume at that pressure. So in other words, these two occur at the same time. Here's the new volume, and here's the new pressure. And again, those two occur at the same time. Right? Now, it doesn't matter what units you have so long as your units match. So in other words, if your volume is in liters, your second volume has to be in liters. Okay, so they just have to match, but it doesn't matter what they are. Now, why is it inverse? Because when one property increases, the other decreases. I find that most people don't have a problem with that idea.